I'm putting this slide up. If nothing else, make sure you have this link right here. And this is the workshops that we're going to do today. So it's exercise, or it says this link, and I'm going to give you another link in a few minutes. Exercise 0 through 4B. And this what you would do here. I'm kind of giving up on us doing this in the class because I think our account situation is kind of not working at the moment. But in this one, basically, you're going to create a Cloud9 workspace. You can also do it locally if you want. How many of y'all use Visual Studio Code? Anybody? All right, good. That's a good one. Okay, good one. What else? What other kind of IDEs do you use? Eclipse.
PyCharm.
What's that? PyCharm? Okay, good. Yeah. JetBrains, great.
Visual Studio.
Visual Studio. Okay. So. All right. So you can use it. So you can set up a local environment. There are not instructions how to do this, but basically, AWS CLI and the instructions are you kind of put together. But if you do it through Cloud9, this will walk through this. So you set up Cloud9. You'll create a website. And it'll teach you how to deploy that. Then you'll end up creating a backend for it and an authentication. So we'll kind of talk you through. And basically, you'll have what we were talking about on the hosted in cloud and different things like that. And then 4B, so that's all the way 0 to 4. 4B is one I have added to this just for you guys. That's why it's a weird 4B naming. What it is it allows you to do the whole thing again using SAM. Takes a lot less time, and I want to show you the example. And what you'll do is you'll actually get the template, you'll package the template, you'll deploy the template. Okay? And it'll build the entire infrastructure for the back end that way. The last part of that at the end of 4B is there's a cleanup section. So it'll show you how to clean it all up so you don't pay for anything if you left it out there running, although this is all serverless. So, the only thing you would pay for in this is storage, and it's dirt cheap. I don't know, what's less than a ruble? What's the equivalent of a penny? What is it?
We don't have it really.
Yeah, okay.
It's so small.
Is that what a CKP? Okay, all right, yeah, okay. Anyway, it's very cheap. So that's what this one is. Okay? At the end of this next session, so if you can all make sure you take a picture of this or write this down so you have it. And then at the end of the next session, I'll give you another link that's the last exercise. But let's go ahead and we'll jump into the next session. Okay, so taking AWS serverless applications to the next level. So we talked about some concepts that we've already talked about here today, but so a little more depth. Some of them I have to review, and I'll kind of cruise past through that, but so you kind of get an understanding. So the why we're here today, obviously, is we want to look at best practices for improving, configuration and deployment, security, code reuse, and more. Okay. Serverless, like any other technology, has best practices. And some of these are just general code best practices. But some ideas to understand when we're building this out. I feel like we're still missing a couple, and I feel really bad for starting. Is he? Okay, all right. Are we okay to start, or should we wait?
I don't know.
Okay, yeah. You know what? Is anybody else missing? Is he the only one? Yeah. Okay, all righty. I'll catch him up. He's pretty quick. So, all right. So that's what we're going to be doing here. Okay. So you saw this pattern. If you remember, just kind of reminder when we talk about serverless, the event, you have a function, and it takes some action. Anatomy, like we talked about. This is not an entire repeat. Sorry, just a couple slides. All right, so let's expand on this. So remember, we have the three things we need to worry about. We have our handler, which I showed you how to do that. You have the event, and you have the context object. Okay? So when we look at an anatomy of function, so we start getting bigger. Now earlier I showed you the big lambda function, the async, the smaller ones. When we start building these out, you have a handler, and now we've got some sub-functions that we want to show. In my example, I showed you that I was using some sub-functions. Okay. Now these functions will begin to grow in complexity, and they get bigger with business logic sub-functions. So as we start to add, now we've got some pre-handler functions that we're going to do. For instance, we're keeping our secrets outside of our lambda. We're keeping it in a secure place. Hey, you haven't missed much. We just got started. So we're talking about the anatomy of the lambda and more depth. And then we're also going to handle some DB connections. We were talking about SQL earlier, and so handle DB connections, clean up things like that. You've also got dependencies, configuration information, common helper functions, things like that. These are common helper functions down here. So take that idea, okay, and think about your example that says, you have an API-based workload, and it's going to have an orders endpoint, forums, search, list, users, and any other number of endpoints. Okay? Take that. Each of these need to read and write to a DB, and they get keys from configuration from an external service. So what ends up happening is each of these lambdas then again call everything, and it gets pretty busy. Okay? I like this picture, it always makes me laugh. This just gets messy. We do not want to deploy this by hand. We don't want to manage the code to get the database connection strings, or to get secrets, or we don't want to manage that in every lambda. We also don't want to manage the deployment of each of those manually. Okay, so this is where we meet SAM. Okay? So AWS SAM is based on CloudFormation. I know we talked about this a little bit, we'll go a little deeper. Okay? If you've never used CloudFormation, again, it's the templates that allow you to build out your infrastructure. And there are some things, this can mix in non-SAM CloudFormation resources in the same template. So other CloudFormations, like a bucket, which I showed you. It supports use of parameters, mappings, and outputs. Now, in CloudFormation or in SAM, I can take the same SAM template and I can pass parameters in as I'm building. So let's say I'm using this same template to build a dev environment. Okay? And maybe I just pass in parameter dev, and maybe I need to pass in a security string. So I can pass those as I'm building. I can use the same template to build to production with different parameters. So I can use it's parameterized, so I can use the same template over and over. Okay? Same with mapping. Mappings are lookups. It's kind of a funky thing in cloud, not funky, but in CloudFormation, where I can have a list of stuff and I can do lookups. So basically, where I would use that is if I'm in this region, use this endpoint. If I'm in this region, so on and so forth. And then outputs. Outputs are the ability to put out, when I build one architecture for one, I can have it output a name. Like let's say I have a security and I have a user pool ID. I could build a whole security setup and it's going to be used by multiple applications. Then I could build this application and grab that data from this other stack. Okay, so it allows you to pass data cross stack. Okay, so all of that works in SAM, just like CloudFormation, as well as intrinsic functions like ref, sub, join, select, and split. These are all ways of referencing and building out from other values. All dynamic data. Import value is what works with the outputs. And then it's YAML or JSON. All right, let's take a vote. Who are my JSON people? Who are my YAML people? Okay, there we go. Now, you were kind of iffy. You're like, was that like when they made me? Okay, all right. So I used to be a JSON guy all the way. I'm now a YAML guy. I really like YAML a lot. It's a little frustrating when you want like something to clean it up because there isn't an app yet that knows how to clean up YAML for you like JSON. But I do like how tight it is and how small the line. What you're doing in like 5 lines of JSON could be in 2 lines of YAML a lot of times. I also love the joke that says my other data center is a YAML. Anybody get that? All right. You can build a whole data center from a YAML file in CloudFormation. Almost. That's probably a little bit of an exaggeration. All right. So you saw this slide earlier. SAM command line interface. Again, it does a lot. It runs on Docker. So you run locally. You can run Docker. With SAM local, you can invoke the Lambda. You can start the Lambda, which means it's up and waiting every time you hit it. You can start the API, which means you interact with the Lambda through an API. Really cool if you're doing local development. So let's say I run local development. I run on my port 8080 or whatever the standard port for local is in React and Angular. Vue, it's 8080, and that's the only one that counts. But then I can also spin up my API on port 3000. I port my local host at that API, and I have I have a local serverless application. Now, one of the cool things is let's say I'm using Dynamo, or I'm using SNS, or one of the services we talked about. Your local infrastructure, if you have internet, can call out to those using your local credentials. Okay, so you don't have to replicate all of cloud local. All you're replicating local is the Lambda itself and the API gateway, because then you can iterate very fast against it. Okay, so and it'll call if it's something Dynamo, it'll call Dynamo. So you can do that. Right. So when we're talking about SAM templates, there's several different resources that are basic, native to serverless. First, there's the function, which we've talked about already. There's the API. Now, you remember in the function, we did an event for API. Hey, how's it going? So we did an event calling the API. You can also, if you need to do more with the API, you can also build and actually separate it out into its own resource. Anybody do Swagger in here or Open API? Okay, because you have to. Yeah, because that's hard. Swagger's hard stuff. Yeah, so you can use a Swagger definition right in this if you wanted to. And there are some specific tags that you can use that relate to API gateway. You can also define the API gateway directly in here. You can get more particular. So we have a simple table, and I showed you in mine where I had a long definition because I wanted to add the global secondary index. But this is all you need to create a table. This will create a table, and it'll default to index as the or ID as the index. So we have a layer version, which we'll talk about layers more, but I actually explained layers kind of high level. You can actually manage the layers right within your same table as well, or your same template, sorry. And then we have the application resource. Remember I talked about the serverless application repository, where you could do sub-applications? This is how you would manage it. Okay, you can actually import an application. So you would say, hey, I want to do this application. This isn't to create the application, this actually imports the application. So, all right. I'm sorry, this is to create the application to metadata. I apologize. All right, some of the different triggers you can use are event sources. These are not all of them. These are just kind of some of the main ones. S3, SNS, Kinesis or DynamoDB, API, the scheduled one, CloudWatch event, an IoT rule. Does anybody work with IoT in here? Okay, a little bit. All right. Serverless is huge for IoT. The ability to have a backend for your IoT. One of the things, and you guys can tell me I'm wrong on this, but I think one of the problems we have with IoT, this is just Eric talking, not AWS today. This is an Eric opinion. We build the cool gadgets, and security is a lot of times the last thing we think about, isn't it? Sometimes, I'm not saying you guys do that. I'm not calling you out. You're like, well, hey, we don't even know you. But I've seen, I mean, IoT, there was a report done, a guy put a camera outside of his network, just on Wi-Fi publicly, and it was 90 seconds before it was hit. It was hit by or scanned, and then shortly after that, infiltrated. So the IoT gets hit immediately. And yes, IoT and hardware, you have to do that obviously, but the IoT network as well. With AWS, you get all the AWS securities around an IoT. We have an entire IoT infrastructure built out. And it works on serverless just great. Alexa is a great example Speaking of that, Alexa skills. Anytime you talk to Alexa, which I know you guys don't do, but I have 4 or 5 in my house, and I love being able to go, hey Alexa, play this, or hey Alexa, what time is it, or hey Alexa, convert Fahrenheit to Celsius because I'm going to Russia and it's cold. So, and when she tells me how cold it is, it's cold. That's all driven by a Lambda. So you can do those events there. So how does SAM help? Well, so first there's a couple things that are real helpful, and you saw examples of it in my template. First of all, it provides globals. So, man, I didn't turn the mic on. We have to start over, guys. I'm just kidding. All right, slow down. I'm sorry. So first of all, SAM globals helps a lot. And this allows you to say, if I have 20 lambdas in my application, which might be a little much, you might want to break that out, but if I have, let's say, 5, 10, 20 lambdas in my application, I can do a lot of the settings through global. Okay? And global applies to a lot of them. It can apply to lambdas, and it can apply to API. There's some other things. So let's just see how this works. So this is a function. This isn't global. So this is a function. And in it, I'm declaring the handler, runtime, the URI, description, memory size, timeout, policies, layers, environments, events. Okay? So now I have, so this is my cat function. Now I have my dog function. All the settings are the same except for where the code lives. Okay? Well, I don't want to have to maintain that each time. Okay? So what I can do is move all the duplicate stuff into the globals, and then just the pertinent stuff inside of the functions themselves. So when you're using SAM, very helpful to use globals. Again, as I said before, I have an example. Yeah, globals. All right. So if I do memory size 1024 in globals, I can override that at the function itself. So I can say, hey, I want all my functions to be 1024, but this one needs to be, 2048. All right, so that's how globals work. So let's get into layers a little deeper. We talked about layers. Again, we talked about this where let's functions easy share. It's immutable. Talked about this one. Okay. So how Lambda layers work. Okay. So order is important. And I'm actually going to do. We're going to do a little demo of this a little bit. Order is really important on how layers work. Okay, so how I introduce the layers is how it's going to look at. So if my first layer has one version of a package in it, and my second layer has another version of the package in it, which one do you think it's going to take? It's the second one, that's right. So it gets overridden. Okay, so order is important because each layer is in a zip file. They're all extracted in the same path. That's /opt. Each layer can potentially override the previous one, so you want to be careful how you name the layers. This approach can be used to customize the environment. For example, the first layer can be a custom runtime. So I have PHP in my custom runtime, and then I can add some PHP packages in the second layer. So I don't have to cluster them all together, I can break them out. How I generally do it, I don't usually use runtimes. Like I said, I'm a node guy, it's natively supported. So what I do is I have the AWS SDK, and I have the X-Ray SDK, and I put those in one layer. Then I have some common libraries I use, like Lodash or Moment or something like that, and I put those in second. Okay, then I can pull them in together. I don't have to do that. I can put them all in the same one. I just choose to kind of break that out as I see fit. Remember when earlier you were asking the limits, and I said you have a 75 gigabyte limit across the region? The Lambda storage is part of that. Okay, one thing that people might get misunderstood is, hey, I pushed that off to a Lambda, therefore that's not part of my storage. When you create the Lambda, it gets pulled in and it's part of your storage. So be wary if you're loading in some big layers that it can fill it up for you. So it kind of gives you an idea how they're laid out. So when a layer is put in, so like Node knows to look under node modules for its package. So if I call a package and I just do the name, it knows to look in this certain spot for those packages. Okay? So when Lambda layers are created, it's smart enough to path them all correctly. Okay? You can even isolate based on, see, this one's Node.js node modules, and then it will look if it's only compatible with Node 8 or Node 10, then they'll look in this particular directories as well. So they'll look to the global directory for any packages, and then they'll look in the specific versions for version. Okay, does that make sense? You kind of have a, that doesn't make sense look in my face. Okay, you good? All right, okay, all right. All right, Python same way, Java, Ruby, and then there's an all where you can drop things in as well. Get the idea, bin lib. Okay, so now let's come back to this idea here. So we were looking at this, and now we've got code in each one. There's a lot of duplicated code here. What we really want is something like this. Okay, so what I can do is I have layers that manage the connection to Amazon DynamoDB and the parameter store, and I remove those. I don't have to worry about them. They're outside of my lambdas. Okay, cleaner code, right? All right, so that's a way of seeing how. We'll come back to an example a little bit. Okay, so the lambda permissions model, we talked about this already. I don't think I need to go any further than this, but basic idea is understanding the function policy and the execution role. Okay? All right, so SAM template policies. I said, I pulled this out and kind of explained how you can apply policies that are managed. This is the page that I was talking about. If you want to grab this link, if you plan on doing serverless, very helpful. Bit.ly SAM-poll. This is a whole list of our managed policies that you can use from within SAM that are very helpful. Rather than, you can always do it on your own, write your own policies, but if you do it this way, then you have a lot of control. You can pass in parameters. So this and each one kind of gives an example of how it's done. All right. So for example, this one is the SQS polar policy, and it'll tell you the policies that you can use. All right. So AWS Lambda environment variables. Okay, key value pairs that you can. So this is variables you can pass into Lambda. Now, key value pairs that you dynamically pass to your function. They're available via standard environment variable APIs, such as like if you use process.environment on Node, whatever, for the other runtimes. You can optionally encrypt these via AWS key management, and it allows you to specify, when we're talking about security, allows you to specify an item, what roles have access to unencrypt it. So it's really useful for creating environments per stage, for developing different things like that. Okay, so this is a way for you to put environment variables into the environment that the Lambda is running in, and you can pass these in through SAM. So really good example to use this is when I create a table, rather than hard coding the table name into my code, instead I pass it as an environment variable. So here in the template my table's created, a little bit lower my function's created, and I reference that table name as an environment variable. Okay, so now I can run the template here, and each one of those has a different table name, but the function's going to know the name because it's grabbing it through environment variable. Don't hard code resource names into your code. Okay, pass environment variables, and you can grab them dynamically. All right. So gateway stage variables. I want to just check something real quick here. Bear with me, please. Yes, okay. So gateway, API gateway variables, okay? These are things that most likely you won't use, but you might. Where they come in handy is if I have to pass, if I'm hitting multiple endpoints behind a single API, I can pass different variables. The environment variables are stored at the API itself. This comes in handy if I need to maintain multiple versions of an API, so backwards compatible. So I may have a V1, a V2, a V3. Okay, and they'll hit the same lambdas, but you can pass stage variables to let the lambda know. Okay, different things you can do there. So here is the best practice for storing secrets. So if you have to store passwords, things like that, we have a thing called the AWS Systems Manager Parameter Store in serverless or outside of serverless. If you're using AWS, this is a great place to store your secrets. And the way this works is you can either grab the value as you're creating the lambda from the SAM template that we've been talking about, or you can access the value from within your code. This is Python. What's up? I did a Python example. It happens rarely, but I didn't make this example. That's probably why. So the availability, or the idea here is from right within the code, I can grab a value. So if I have like an API key, if I'm making a call to Stripe or something like that, I can grab that value and pull it in. Very handy. The nice thing about having it in the code is you can go in, this is an account-specific value. So within your AWS account, you have a parameter store, and I can write data, I can encrypt that data, and I can tell it, hey, only these roles can unencrypt it. That's the roles from the Lambda. So not just anybody can go in and look. Someone else signed into the account with the different credentials. They can't go look either. So, great way for storing, centralizing environment variables, secrets, controls, feature flags, things like that. So this goes back to the idea on Lambda. When we're dealing with Lambda, we can do stages. This is the stage variables I was talking about. So I might have multiple stages on the API gateway, a beta, a dev, and a prod, and I can map those to specific Lambda versions. Lambda has alias and versions. So my alias would be prod, and my versions would be like version 3, version 6, version 9. So let me tell you this. If you're looking at this, kind of scratching your head and going, this doesn't make sense, or why would I ever use this? Probably you won't, to be honest. It's available in case you need to manage different ones, but it's not how we suggest it. Let me ask you guys this. How many of y'all have a CI/CD process? Okay. All right. How many of y'all, and let's be honest in the room, does anybody not know what CI/CD is? Okay. Okay, that's great. Thank you. CI/CD is continuous integration, continuous development, or deployment, depending on what you do. But what it means is it's a way for developers to check in code, and it's automatically compiled, merged. Actually, they merge it, it's automatically compiled, and then it's usually deployed to a testing environment. Okay, something like dev, or alpha, or gamma, or Mary, or Bob, or Vlad, or whatever. So I mean, it's you can name it, and the idea is that you can there's an automated process to move it along. So it was always funny. In my previous life, I was a solutions architect, and I would sit down with companies and talk to them about solutions architects, or I'm sorry, about CI/CDs, and I'd always ask, tell me your CI/CD story. Oh yeah, we're fully automated. All right, well tell me about it. Oh well, Bob compiles it on his desk. Well, here's the truth. If your CI/CD has somebody's name in it, it's not automated. Okay, so you need an automated process to do that. But also, I want to talk about environments. A lot of times when we look at environments, one of the things we struggle with as developers, and raise your hand if this is true, it works on my desk, right? And developers, that's our big, hey, it worked on my desk, that's what we say. But we push it to development, and development crashed because the right dependencies weren't there, the right things like that. Or it worked in development staging, but we couldn't get it out to production because the memory wasn't the same, or the bandwidth, things like that. We deal with these environmental differences all the time, don't we? Yeah. So one of the things that we heavily encourage in serverless, and one of the beauties about serverless is because you're not talking about environments sitting out there, you're talking about invoking, is serverless replicating environments is very easy. And so the best practice we talk about when you do environments or CI/CD or whatever with serverless is a separate account per environment. Each developer gets their own account, and each environment has their own account. Okay? And when you're all serverless, cost is the same any way you look at it. Now, and the nice thing is that 1,400,000 invocation, he gets 1,400,000 gigabyte. He gets 1,000,000 for it. It's not spread across these. So each one gets that's per account. Okay? So you save some money that way. But if I do this, then I'm not having to worry about parameters and stage values and aliases and things like that. All I'm worrying about is accounts. So this is our best practice when we talk about doing multiple accounts. So you can use that SAM template like I was talking about, or some type of framework, and you just push the different accounts. You store it to GitHub. He pulls it to deploy. He pulls it to deploy. You pull it to deploy. I pull it. I can deploy. If you absolutely have to manage multiple ones, then again, you can come back to this and you can manage this out. All right, any questions on that? That was kind of probably a lot of information, especially if you've never done serverless. But yeah.
Is this issue Lambda has own version history, or you put all your environment, all set of Lambda set in version, which I could release at all, or each Lambda I should release personally?
Okay, so I'm going to repeat the question, make sure I understand. So, do you release all lambdas at one time, or is each lambda released on itself? Generally, you can do either way, okay? So what we talk about are applications being launched. An application can have 2 or 3 lambdas, but the lambdas roll out, like if I'm doing a rollout on CI/CD and one lambda crashes, it's going to stop the workflow, right? It's going to roll back. So you could separate them, or you could do a bunch at a time. What we generally do is really encourage best practices to say, I'm going to logically separate my application. So let's say I have an application that does 10 or 12 things. If I have several behind 2 or 3 endpoints that are logically together, that's one application. This is an application doing image management, things like that. It's maybe 5 lambdas, stuff like that. Here's another one. These are different repos. And so I'll push those in the same. I generally try not to release, just had an email about a customer who's trying to release like 900 lambdas at one time. Oh, the chances of all 900 going out are pretty good, but chances that, it gets higher the more you're running out. It's some growth, So, did that answer your question?
Yeah, I want to ask, some lambdas could be mutated between, so one new version of one lambda could depends on another version of second lambda. So, is it easily manageable, this version dependencies?
For here, like this, yeah, I mean, it can be done. So it's not, sometimes it's manual changes, or you can do an API to shift, to say point B1 at 0.7 instead of 0.6, or you can automate that through scripting as well. We do a thing when deploying this, a little outside scope, but that's all right, we've got the time. We do a thing called canary releases in Lambda. Are you familiar with the idea of canary release? Does that make sense? Anybody ever heard of canary release? Okay. All right, what's that?
Like 90 days.
Like 90?
90.
Oh, 90. No. Well, okay, no. But I didn't say it's not a 90 build. So a canary release, I'm sorry, my deaf and accents and it's just, yeah. But so a canary release, what we do is we say, all right, and you can do this per lambda, okay? You can say, I'm going to tell this lambda, I want you to deploy to 10% of my traffic. So if I have 100 people coming in, it's only 10 people are going to get it. And we're going to do that for 10 minutes.
On the user group.
Well, it's not really, it's just kind of random, but yeah. And then if in 10 minutes all looks good, then shift all traffic to the new one and move on. And it handles that by this. I think I actually, in my layout, let me check real quick here. Yeah, I do actually talk about that. So let me go a little further, and I think I'll answer your question. All right. So, safe deploys. Here we are. So we do this thing called safe deploys, okay? And it includes a canary release. So what it does is, and the safe deploy part is everything down here that's in the pane. One of the things we do, and you don't have to understand what all this means, but we create an alias, okay? And that's by saying auto publish alias, okay? And then we give it a preference. So this is called linear 10% every 10 minutes, or the other option is to go canary, okay? And that means canary for 10 minutes and then everything, okay? So, and then we can list alarms that it's based on, and then you can even have post and pre-traffic hooks. Let me show you what that means. So, different options. You see canary 10%, 30 minutes, canary 10%. So, canary means a little bit until it passes all tests for a certain amount of time, and then everything. Linear means 10%. So, we're going to go 10%, then 20%, then 30%, then 40%. So, linear, out that way. Okay? Or then all at once. All at once is default. Boom, there it is. Okay? you could check to see if all your versions are matching.
So I have some red button to start with the deployment.
Yeah, you could go in and go, no, you could kill it, exactly. Okay, so then this post and pre-hook that I was talking about, okay, so this is one of the few times that we have a lambda call a lambda, okay, so you can actually declare a pre-test lambda and a post-traffic lambda, pre-traffic lambda, post-traffic lambda, and what it'll do is, it could be the same lambda, depending on how it works, it'll be given the address to the new code, and you can test it. So you can say, hey, I need to check these versions, make sure they're working. Okay, all is good. Let's go ahead and push the rest of the traffic. After all the traffic goes out, then we can hit it with another lambda. Maybe you need to check load. Maybe you need something like that. So then you can also check. So you don't have to use both. You can use one or the other or neither. Okay, but it lets you check your versions to make sure that everything's out and in place. If it isn't, then it'll roll back. So, does that help? Okay. Yeah. All right. Hey, good timing. It's a good segue. All right. So, this is how it works. Kind of basically what you get is it actually handles the API. It'll point to the different versions. This isn't that important. To be honest, I'm not sure why I let this slide in. But we do it through traffic shipping by pointing at aliases all under the hood. You don't have to worry about all that. All right, so I already talked about the service application repository. So this gives you an idea, again, of what the service application repository does. And we already kind of talked about this, so I'm not going to go into terrible depth on this. But I do want to kind of show the example, okay? So we've got nested service applications that do different things. Let's say this first one does some image stuff. The second one does some audio stuff. The third does some analytics stuff. They're all pretty vanilla type plain applications that are meant to be used elsewhere. I can install those as part of my root serverless stack. So what I've almost basically done is I've taken an application built from other applications. Okay, great in places where you work in enterprise where you want to share out modules. Say, look, I've already built a function that does image magic and does some stuff. I've already built an analytics tool. I've already built a compression tool, whatever you may be doing. And here it is. And the SAR, the service application repo, you can make that to where only people, your permissions can control who sees it. So, hey, this is just in our company. This is public. This is just this region, whatever. So you have a lot of control there. All right, so in kind of closing this out, and we booked on that was fast. All right, so in doing serverless, use a tool like SAM. I really encourage you, if you're going to get into serverless, look at SAM. Serverless framework, another great framework. They're a partner of ours, great framework. SAM's an internal one. I love SAM, but that's just my opinion. We really encourage you to use a framework. When you're looking at environment variables, use systems manager parameter store for security. And then for sharing things out, use globals and use layers. All right, again, same application. What questions do you have? That was a lot of info I passed it to. Any questions on that? I'm going to show a layers demo here in a few minutes, but what else can I answer?
I don't really catch why do we need these layers.
Okay.
Because we can replace it but independently. Or why?
Why use the layers?
Yes.
Okay, that's it. All right, I'll show you. That's it. I like that question. So let me dig in here and I'll show you. Layers are not. Let me say this. You don't have to use layers. They're an option to use. Okay, layers are a good way to share code across multiple lanes. Okay, you can if it's packaging, you can package them up and use them the same way. I can do it that way. But layers are a good way to share things across multiple. Let me show you an example here. All right. couple things we're going to do. Where's my, here it is, Cloud9. Okay, so, actually, before we do that, let's jump in. Let's just jump over here, change to Oregon, go back to. Okay, so, first thing we would do, so I've got some layers already built in here, okay? So these are, there's a couple in the AWS, there's the version, this is the address on how to use them, and so on. So first thing to kind of show why I would use a layer is for SDKs, okay? SDKs in AWS is that's how I interface with the rest of the system, okay? So from Lambda, I can use Software Development Kit, and I can interface with Dynamo, S3, SageMaker, does, you know, all of our services. That's how we do it. And we build them out for all our native languages, okay? But in Lambda, when you have a Lambda, you automatically have an SDK, okay? If I'm running Node, I already have the Node SDK. So let me show you something. Here, functions, and here we go. No, that's the runtime. Give me 1 second. Okay. I need to find the right function so this makes sense. Bear with me 1 moment. Let's let example runtime. Well, I'm in the right area. Oh, I know. There we go. All right, so I have this simple function, okay? And all it does right now is it requires the AWS SDK. Now remember I said all our lambdas come with an SDK included, okay? For whatever runtime I'm running. So I'm running Node 8.10, and I've got this array of colors, and then what I'm gonna do is I'm gonna list the AWS version, and I'm going to list the colors. Okay, so let's go ahead and test this. Okay, and my response, there it is. My version is 2.528, and those are my colors: red, blue, green, whatever. Now, let me check something real quick here. Layers. All right, so I have one layer. All right, so I have the SDK layer attached. Let me remove that real quick. We'll save it. Let me test it again. You see the version there? 2.44 or 2.488. That's the latest. That's not the latest version of the SDK, but that's the latest one the Lambda has attached to it. So when we do these Lambdas, we do update them periodically, but they're not always the latest because the SDKs change all the time. If you want control of which SDK will always be loaded up, you can do it through a layer. So let me reattach that layer so you can see. So if I add that layer in, and I'm going to just say my AWS SDK, oops, version, which version I want, save it, and test. Now for Node, versioning isn't as big a deal, but I know a lot of things can be in Ruby, very sensitive to which version, backwards compatibility. So notice I've got the newer version. So now, if I want to update the version, I create a new layer version of that, and I update it, and then I can update my lambdas to take the latest one. So that's one reason. Now I could go out and I could package into each lambda, and I'll actually show you this real quick here. So let's All right, so we're going to see. Let's do it this time. Okay, so get a little SAM. This is going to be a little SAM example that you're going to see. If I want to create a Node app, so first of all, let me just do SAM init. Oh, okay. Kind of show the idea of things I can do here. I can use SAM to initialize my app. Okay. So for runtime, I have the multiple runtimes. I can set a dependency manager, output directory, so on and so forth. So I'm going to say SAM init. The default is Node, because that's our most common one that's used. And I'm going to put a name on it. I'm going to call it okay. All right. So, oh hey, how's it going? All right, so I now have an app inside Lexus. So let's open this up. Okay, this will look like the serverless app that we had before. It just creates a hello world before. So I can, if I want, I can go into hello world, and I can go npm install, and if you're not a Node person, not a big deal, but we're going to do AWS SDK and Lodash. We'll just do those two for now. All right, so these are packages that I'm going to use across my layers. Normal libraries use them all everywhere. Okay, so I've just added them to this Lambda, and they're added under the application. So if I go over here, and here they all are. This is a perfectly viable way. So when I push this Lambda up, it'll take those packages and off we go. Or I can Webpack it. If you deal with Node, some kind of, you can do Webpack where it pulls it all together, however you want to deal with it. However, the size that I'm going to upload, as these get bigger, I'm re-uploading packages over and over and over that I don't need to upload. Instead, if I have a Lambda layer, then that layer, when I upload this, then that layer will get pulled over and it'll be put, instead of me uploading that package every time. That's another reason that we use layers. There are other ones, but you don't have to, but it makes it very helpful. What other questions on layers? Or what you're seeing here? Glad to show anything.
So just like a package of packages.
Yeah, kinda. It's a way to isolate and version your packages. The versioning is a big deal. You're able to say, look, this version's out, and I pushed a new version. Your choice whether you want to use the new version or not. The version's a big deal on that, and how you maintain them. How I generally do it is like I said, I have my standard packages that I use. Then I have some libraries that I use, and then if I have some clients, application-specific clients, I still, because it's going to go across multiple lambdas, I will still package those up. If I'm editing them a lot, I will actually keep it within the project, and then each time I push, that if I change those, it will create a new version, and I can grab the latest, and then once I'm done, I'll take it outside the project. Does that make sense, or is that confusing? Make it more confusing? Yeah.
What is typical realization of layers? Maybe it's layers set up on every Lambda call, or maybe it have prepared like containers for it. Does it spend time on each Lambda call or not?
I'm not sure I understand. I'm sorry.
When we have prepared layers.
Okay.
When next Lambda call, does it spend time on layer implementation?
No. Okay, I see what you're saying. So, no, that's a great question. So if you think about it, so here, let me show you kind of an example. All right, so there's AWS layer, okay? So let's say over here, Sally has a layer that she's written. Okay, you've got 3 versions of it. Those are the layers. Okay, and here's you. I'm not an artist, so put 1 finger though. Okay, all right, and I'm bald. So, all right. So that's now it's me, not you. So if I create the layer, what I do is I package up the layer, okay, or my part of it, not the layer, I'm sorry. I'm creating the lambda. I package up the lambda, okay? So I end up getting a zip file. Okay? It's going to go out here, and then the lambda service is going to call the version of the layer, pull it all together. It's going to package it all together in AWS. Okay? No, you're never going to call from here again unless you update this. Okay? So yeah, so that's what makes it immutable, and that's what makes it where it's not going to break your system if she does. So if she goes out and deletes this, it's still here for you, just fine. So does that help? Okay. Yeah. No, and that's a good question, because one of the things you think about is latency, and to go out and grab the zip every time, that would take a lot. So and that's something to think about when you're building any application, and specifically service applications. What other questions? Does this make sense? I'm quite the artist. I'm not trying to brag, but I really am. So, all right. Okay. So let's go back into the versions here real quick, or into the layers. All right. So a couple other things to look at with layers. So we looked at how you can add the SDK. Now we're going to add another layer. If I can. There we go. Okay, so I'm going to add a utilities layer. Okay. And this one has, in this, it's got my Lodash and things like that. Now if I go to my code, I can go here, and I can actually now call moment and numeral. Those are 2 that I use. And we'll actually, I'll put a formatted numeral, a moment number, and a formatted numeral. So we save that. Alrighty, come on now. And we're going to test it. Okay. So now you can see I've loaded the library, so I've formatted the number, I've done the moment. So that's really helpful. So pretty clear, load packages up, and you can see in Node how I'm calling these. These are just straight up package names. But let's look at the colors. I'm actually declaring a constant here with colors in it. What if instead I load those colors externally? Okay, so I'm going to require a file. So I can literally say here, now if I were to do this without the layer, it's going to blow up on me. Okay, you can see here that it can't find that file there. So instead, I'm going to go ahead and add the layer. And let's add the colors. Data layer. Save it. You always have to save it. And test. Now my colors are yellow, purple, violet, brown, and blue. So loading up. So what that is this is really helpful, and I'll show you a great example of this in the code. This is helpful in just static data, okay? I don't really need to load all the colors, but one of the things that I had in the translation app I showed you all earlier, 2 services I'm using are Translate and Poly, okay? Translate does a bunch of languages, and Poly supports a bunch of languages, but they're not the same languages. There's some that match and some that don't. So I have a static JSON that maps, that says, all right, you could, and first of all, it lists all the available ones. So I'm only allowing us to do ones that are supporting both services. Okay, and I just did that in a JSON file, and I have it in a layer. stored it in the static layers. It's a great way to use layers. One other thing I'm going to show you on layers here. We'll take a break. So, actually two things I'm going to show you. I'm going to add one more layer. Oops. And I'm going to save that. And this is just to kind of re-add or reinforce. Look at my version now, 2.146. That's going to break my application, right? If I were running a real application. That's because in that old layer, I have an old version of the SDK. And because it comes last, that's the one that's implemented. So again, order matters, and it's really important to do that. All right, let me show you one other. Back to functions here. Okay, so this one, let me show you the function on this. Okay, I'm running, this is my function code, it's bash script. Okay, remember I talked about custom runtimes. If I were to run this right now, okay, so if I were to run this, it's going to blow up, okay? But I can go back in, I just removed it so I can add it back, add a layer, and I've got a custom runtime layer. Notice I can't add it in the dropdown, okay? Because this is a custom runtime layer. Compatibility is kind of hard to tell, so we're not able to just say, hey, what are the compatible layers? So for this one, I need to provide a layer version. So actually, I'm going to go back to my layers. Okay. So in here, I have the runtime layer here. I'm going to take it, copy it, and I'm going to paste it in here. I'm going to add it. Okay. Save it. There you go. I now have a Lambda that I could run behind an API gateway if I wanted that is written in bash script. Anybody want to run this? Probably not. Probably not the best language for doing that. But the point is, you have all kinds of flexibility and you can really do anything you want with this. So, and that's it on layers. Hopefully I answered the question of why you use layers. There's we have a group called Serverless Heroes, and these are people that are just always talking about serverless. And so one of our serverless heroes, he's like, I don't use it. He just packs npm pack. He packs it all up in each one, and that's fine. It really is. It's a fair and decent way of doing it. I think this is easier. This removes. I think you were saying you do Node maybe in Node or in JavaScript we use a thing called Webpack, and that'll go through and get all your dependencies, kind of put them all together. This removes my need for using that. If I put all my dependencies out, I know my dependencies are going to be available in their fullness. And then I can write straight up JavaScript. Now let me ask you a question. You saw me, I was updating the layer in the dashboard and doing that. Anybody see a problem with writing serverless code that way? Yeah? Everything I just did was immediately in production. So I probably wouldn't choose to do, that's not the way I would approach it. Remember I talked about using a framework and using SAM? I would tell you, get in the dashboard and play around, but every time I do that, it's public. I save it and it's public, right? So I can go out there and I can update that code and it's always in production. So that's what we set up. That's why we set up, dev environments and staging environments and production environments. All right. So what we're going to do, they're going to come in at about 3:30. I think they wanted to take some pictures. I don't know why you took a picture of this, but apparently they do. And then I have one more where I think, like I said, we've given up on the workshops themselves in here. But did everybody get the links? Okay, and everybody wrote down my Twitter handle. Does everybody do Twitter? How about I do this? Do you all know what Twitter is? Okay. Let's do this too. Small here. There you go. I'm not putting my phone number up there. But feel free to email me. I'm not going to be able to, I probably won't respond immediately, but I do help. And I'll be glad to help. I can also point you. And it may be in the help of, hey, here's the documentation, check this out. Or yeah, click here, push that, do this. Or, man, I got no idea what you're talking about, but I'll try my best. So, glad to help either way. Twitter is a faster way to get me, to be honest. Just because that's part of our normal, we're always on there and stuff. But my email address is another good way to do this. So what we're going to do is, they're gonna, like we said, let's take a 10-minute break. They're going to come back in at 3:30 and take pictures. Then I've got one more thing I'm going to show you. Probably won't take very long, and then we'll be done. So does that work? All right. Thank you.